My name is Matthias Hempel. I'm from the University of Basel in the group of Professor Liebendörfer. And so I came here to get an overview of the different projects which are here. So people are working at the CSCS on. And so until now I couldn't meet the people from the CSCS, and so now this is a good occasion to get to know people and also to present my own work. And yeah, so and we had a lot of interesting presentations, and yeah, so now I can come and present my own work here. So it's about stellar explosions. So one knows that at the end of the life of a star you have first a collapse, and then one expects that this collapse leads finally to a very energetic explosion. And so we observe them, like you can see here. So they can be so bright that they even outshine the surrounding stars of an entire galaxy, or that you can even see them at the day sky. And we still don't know in detail how these explosions occur. And so from simulations, one knows that in spherical symmetry, you do not get these explosions. So that's why we need here multi-dimensional hydrodynamic simulations of the collapse and then the ongoing processes in such a core collapse supernova. And and then we have another aspect which we want to study here. So you need to know the thermodynamic properties of nuclear matter under these conditions. And for this you need an equation of state, so where you have as an input the nuclear interactions. And so we have some constraints from experiments and from astronomical observations, but still there's some room of uncertainty. And so we develop new models for these, or we apply new models for these nuclear interactions, and then we want to study what the effect is on these dynamical simulations here. And so on the other hand, then also the aim is that if you would observe such a supernova, so that we can make predictions, like here in this plot here, so that you, for example, you would measure the time until black hole formation, so of the collapse of a very massive star. And if you, let's say, it would form after 0.9 seconds, and then you would know, okay, from this correlation which we found here, that the maximum mass of a neutron star has to be as large as at least 2 solar masses. So this is a property of the equation of state, and it would not be possible to get this information from experiments which are performed here on Earth. That's it.